That's the essence of model view controller. And the reason to introduce it is that Rails can be said to be a model view controller framework. What that means is that Rails is very opinionated about the structure of the apps that are built with it. And the good news is that if you're in agreement with those opinions, if your app is a good fit for the model view controller design pattern, there is a lot of work that you don't have to do because the framework does it for you. But if you try to shoehorn an app into this model that isn't really a good fit for the model view controller organization, you will be fighting it every step of the way. So what does it mean to say that Rails is an MVC-based framework? Well, for one thing, that means that each kind of thing that an app manipulates, so going back to our movie example, there's going to be a controller, a set of views, and a model that is related to that kind of thing. So in our simple movie app, there's a resource for movies, there's another resource for reviews, and there's a third resource for users. Right? You can see how, there may be more things too, but at its most basic level, we sort of need three kinds of things. And why does each of these kind of things potentially have multiple views? Well, one simple reason is that if you think back to the main actions you can do on a resource, like create, read, update, and delete, there might be some views that give you lists of things, like movies filtered by some criteria, but there might be other views related to movies that let you enter or change or update information about one. So each model is associated with its own controller, probably with one or more views. And that means that the task of determining when an incoming URI arrives, which action is supposed to be fired, gets a little bit more complicated. Because in the Sinatra version, there was really just a single file called app.rb. In that file, there were routes matching different HTTP methods and URI patterns. But now, in Rails, there's potentially many controllers because there's many resources. So we have to add a layer in front of it that Rails calls the routing system. We have to add a layer in front of it that Rails calls the routing system, whose job it is to basically figure this out, right? So here's the first difference between Rails and Sinatra. In Sinatra, the routes, in some sense, are hardwired into your app.rb file. In Rails, there is a whole separate mechanism whose only job in life is to figure out that mapping. It's sort of adding a level of indirection there. What else? Well, the models have to store their state somewhere. And remember, MVC says nothing about how or where that happens, but the Rails framework does. It says models shall store their state in a relational database. So corresponding to each model in your app, there will be a database table that stores instances of that kind of model. We'll talk a lot more about that in just a moment. And again, each one of the resource probably has its own table, and we'll use the mechanics of relational databases and relational algebra to enforce relationships among them. For example, when a review is written, you want to know who wrote it and you want to know which movie it's about. So if you've done database work before, we will use foreign keys to do that. If you haven't done database work before, don't worry about it. It will be explained. So in summary, what's happening here? The app server still passes a request into Rails, but now it's going to go through this level of indirection, the routing subsystem. That will determine which controller action has to be invoked to handle it. And just like Sinatra, the parameters will be parsed out. A bunch of other nice things will happen to insulate your code from some of the details that have to happen at the HTTP level. The controller action will be called. Just like Sinatra, it can result in updating the model state, but now the model state is explicitly stored in a database. Remember, in Sinatra, we had this very simple example of our tic-tac-toe game. The state of the game was basically the board and whose turn it is. And in our simple app, the way we dealt with that, the way we stored it, is just putting it in a cookie and passing it back and forth. Again, for a more complex app, that doesn't scale terribly well. So now the idea of storing and manipulating state has been offloaded to the database, and Rails provides a set of facilities designed to just sort of do that. Just as in Sinatra, a view is ultimately rendered. But again, now the views are sort of associated with each model. So there's sort of some conventions around if there are views that are related to movies, they all live in the same place. They have a number of things in common. You can easily sort of have chunks that are reused from different views. And this is the basic scheme of a Rails app, by the way. Variations exist. There's sort of variations on the theme. But this basic structure, and I'm going to use a little fancy CS term here with which you can impress your colleagues. This basic structure reifies the abstractions of model view controller. Reify is from the Latin word rex, which means king. And to reify something is to make it a king, to recognize it as a first-class thing, as an abstraction that is provided by the framework explicitly to facilitate something. So it reifies the ideas of model views and controllers. It reifies the way that communication happens among them, the way that a controller makes information available to the view, the way that a view passes user-supplied information back into the controller, the way that the model state gets updated in the database. Rails has abstractions for all of these things. And the good news is that if your app is a good fit for MVC, those abstractions do a lot of work for you that otherwise, in a simpler framework, you would have to do by hand. As I said, the bad news is if your app is not a good fit for this framework, you're going to find yourself basically fighting the framework. So if you sort of temporarily pop 2 levels up in abstraction, architecture is about choices. Just like we said, Agile is not always the best methodology. Model view controller is not necessarily the best fit for every app. Client server is not the best fit for every cloud-based or software as a service application. So understanding when the abstraction is a good one is really important, right? That's sort of 70% of the problem, because if you then pick up a framework that reifies the abstraction well, a lot of work is saved and your life just became a lot easier. The other thing to notice about this picture is that everything here is stateless except the database. The database is the only component in this picture that in some sense is shared among the different models. So the good news is that because all those other pieces are not shared, it is sort of trivial to make them stateless, which means you can scale them in the sense of adding more capacity for more users by just having more copies of them, having more hardware running more copies of the processes that correspond, for example, to the controllers or for rendering the views. The bad news is because the database is shared, it's harder to scale. But the good news that goes with the bad news is that good design can take you a long, long way. So one of the questions we used to get in this course a lot is, I've heard that relational databases don't scale, and my app is going to be more popular than all the social networks combined, and it needs to scale. And the answer has always been, first of all, you're not Google and you're not Facebook, which is good for many reasons. But you can get a long, long way. I think people underestimate how powerful traditional database technology has come and how far it can take you with careful design in scaling the database up to much more than you can imagine. The other piece of knowledge, though, is even if you do get to the point where you have absolutely outgrown what a traditional database installation can provide, the kinds of concepts that you'll need to put into practice in order to use a different kind of storage and to scale farther are exactly the same kinds of concepts you need to use to get the most juice out of your relational database in the first place. So there's sort of no magic step where I've ditched my SQL database and now I'm ready to scale. You're going to find yourself solving a lot of problems that SQL solves better than you. And in solving those problems, you're going to have to bring to bear the exact same conceptual knowledge to the challenges of how to overcome what the scaling obstacles really are. If we sort of put that together and say, what does it mean to say that Rails is an MVC framework? Here's our sort of typical communication stack with the user's browser at the bottom, some HTTP servers, an app server that's connected to your app, and a database for storage. So if we sort of look inside the app box, connecting this to the files that are actually created when you start a new Rails app, there's a set of controllers, and they're located in a directory with that name. Each controller is a Ruby file that corresponds to the controller for one of the resources that the app manipulates. There's a routing layer, which we'll talk about more in a separate section, that determines which controller to select for a given request. The controller's subclass from a Rails-provided class called application controller, right? So how do frameworks generally provide things for you? They essentially provide base classes from which you inherit a subclass. And it's the base classes that give you a lot of the nice, tasty functionality that frameworks give you. So in this case, there's a class called application controller. There's a number of common controller-ish behaviors that are accounted for in that class. You just inherit from it for each one of your controllers. The controllers talk to the models. A model is just a Ruby class that is in a subdirectory called models because we are reifying the concept of models and controllers being separate. As we said, each model is associated with a table in a relational database, and we will have more to say about that in just a few minutes when we talk about active record. And each of those models are a subclass of application record, which is a brain-meltingly powerful object relational mapping system that creates the glue between how a model instance looks in Ruby and how it looks when it's stored in the database. And finally, there's views. The views, guess what, are in a subdirectory called views. And in fact, each of the models will have its own subdirectory within views where HTML files that have embedded Ruby in them are stored. Note that as a triviality, where the views in Sinatra are just named file.erb, the example I'm showing here for Rails is file.html.erb. The reason for that is that although the most common kind of view is an HTML page, you can have views that consist of other things. There are other templating systems, there are other output systems that you can use to actually create sort of a more concise versions of HTML. You can output things in JSON, you can output things in XML with minimal changes to the model logic or the controller logic. So Rails actually is able to process views in multiple different formats and include embedded Ruby code, hence the ERB extension. And those are subclasses of yet another framework-provided abstraction, Action View, which does a bunch of nifty things, including, for example, making information that is set up by the controller available to the HTML code in the view. And by the way, we said that the framework reifies any number of things about how model view controller is actually implemented. That was just the sort of software organization. What about where does all of this stuff run? Well, if you're developing on your local computer or in a Codio or other IDE, the database you're using is probably the very simple SQLite 3, which is fine for development and testing. The app server is probably Rack, because that's what sort of comes by default when you fire up Rails locally. The web server is something like WebRick, might be Puma, and the deployment environment, I guess, where everything is running sort of running on one computer, whether it's your own computer or whether it's somewhere in a virtual machine in Codio's IDE cloud. But when you deploy to Heroku, even for the simple chips that you're deploying at the beginning of this course, the database you're using is Heroku's hosted PostgreSQL. They do a bunch of things to make databases very easy to connect to Rails apps. The app server is probably something like Puma or Unicorn, which is tuned to run much better in their environment and scales quite well if you need to make many copies of your app. The web server is this very obscure web server called Cowboy, which was custom written at Heroku in a language I bet many of you have never heard of called Erlang, because it turns out to be very good at doing sort of very simple receive the HTTP request and hand it off. And all of this is running in Heroku's cloud, which in turn is running on top of Amazon Web Services. So the software organization stays exactly the same from your point of view. The hardware deployment environment can be quite different. And when we talk about the notion of environments in Rails, one of the reasons that Rails as a framework reifies the concept of a deployment environment is because sometimes the app needs to make different choices internally depending on where it's deployed. So we'll talk about that more as we talk about deployment and testing. But this is sort of the big picture, right? Rails reifies the concepts of model view controller. It has strong abstractions that define how each of those things is implemented in your app when it's a Rails app. And it has facilities for basically having different implementations, different infrastructure components that can host the database, the app server, the web server, and so on.